Good morning, everyone. Again, my name is Julie LaRose, and I'm a safety consultant with the Wisconsin Consultation Group. Thank you for being a part of the webinar this morning on preventing slip, trips, and falls. I am very passionate about this topic for reasons I'm going to share with you during the next hour, but I really appreciate your participation this morning because this is really a time of year where it can be hard to participate in webinars such as this, but this is a topic area that is so important, particularly for us here in Wisconsin in the Badger State. So what I hope to accomplish in the next hour is first to start about talking about the cost and the human toll of slip, trips, and falls incidents in the workplace. And I hope that I can lay the foundation for why this topic is so important and the opportunities for us to really improve in this area to help ensure that people don't sustain slip, trips, and falls at work and the fairly traumatic injuries that occur as a result. So after developing a really good understanding of why this is such a problem, I want to hone our skills in identifying the risks associated with these injuries. So I want to equip you with hazard identification skills so you can look around your own workplaces and be aware of some of the exposures that can result in some pretty serious injuries. And then lastly, I want to talk about best practices for eliminating or controlling these types of hazards. I've been working in safety and health for 30 years now, and I've seen so many different situations and settings and companies, and I'm going to share stories with you of things that I've learned over the years, hopefully practical ways that you can take back and further improve your own programs. So I think it's important to define the different mechanisms that are involved with someone ultimately hitting the ground. And so the mechanisms for slip, trips, and falls are different. There's so many times in which this will be lumped together, slip, trips, and falls, but the way in which each of these things is occurring is different. And I think it's important to start with a good understanding of that. So the first is a good definition of slips, which is a loss of balance that's really tied to the slipperiness of both your footwear and how you're contacting the surface in which you're walking on. And essentially, it's a loss of traction that is the culprit in workplace slips. And I'm going to talk a little bit more about how that can be measured. So that loss of traction is termed, it can be measured by looking at the coefficient of friction, which is how easily or difficult two different surfaces move past each other. The second is trips, and that these incidents occur whenever your foot hits an object and then you're moving with enough momentum to be thrown off balance. So essentially what happens, the dynamics of these involve your lower body coming to an immediate halt while your upper body continues moving forward. And then falls are considered to occur when your body's center of gravity falls outside a base of support, which is generally typically beyond your feet. And so I thought it would be helpful to have a diagram of what that looks like. And that's what's pictured here. So your center of gravity is relatively around your belly button in the center of your body. And so you are most stable when we're looking at the left-hand part of this picture, where your center of gravity is square, over your feet and you see where your base of support is. Now, your center of gravity, of course, when you're walking or running changes. And as long as that center of gravity stays within your feet, you have a fighting chance of staying upright. As soon as that center of gravity falls outside of that base of support, you're in danger of falling because you are now unstable. Before I move on to the next slide, I'd like to talk about why this topic for me is particularly important. I've experienced in the course of my life slips, trips, and falls. And the boot I have pictured in the lower part of this slide is what I've worn for a total of 9 months of the course of my life now. I've sprained my ankle and rolled it while jumping up from a couch. This past May, I broke my left ankle because I missed a step and wrenched my left ankle, breaking it. Then I was back in a boot again. I partially tore my right Achilles tendon when I was slipping, after I slipped on wet pavement. So I've spent a lot of time in physical therapy and wearing a boot because of slips, trips, and falls. And none of these have been work-related, but each one involved quite a bit of downtime on my part. All of these incidents involved a significant change in my lifestyle over a course of months. I like this photo in terms of explaining again the importance of keeping your center of gravity within your base of support. And this kind of illustrates why when you look at a toddler who's learning to walk or, is just starting to learn how to keep their balance, why it's so much more challenging for a toddler and why it's important for us to kind of keep a close eye on them. You see, for us, our center of gravity and our support base enable us to keep our balance much better than a toddler who, because the toddler's head is larger, disproportionately larger to their body than ours is, their center of gravity is actually up around their shoulders. So you can see that their support base is much smaller and their center of gravity is much higher. So when there's even a 10-degree slope on which they have to walk, their likelihood of falling is much greater than ours. So you can see when you drop the line from our center of gravity, as an adult, we can navigate that and not fall, not so for toddlers. So again, it's good to keep in mind this principle because it comes into play when we're looking at workplace conditions that create hazards. And again, the biomechanics of walking and running is something that's been studied very extensively, and it's a complex ballet. You're using your limbs as well as other parts of your nervous system to help you maintain that center of gravity to prevent yourself from falling. But essentially, your actions enable you to maintain a center of gravity over your feet to prevent yourself from falling. So when looking at how much this is an issue in the state of Wisconsin, we can turn immediately to Wisconsin Emergency Management Services. This is all the emergency departments across the state of Wisconsin. And in 2022, the Wisconsin Emergency Management Service Organization published a report raising a red flag, say, hey, this is a huge problem. Wisconsin EMS in 2022 responded to 911 calls for falls every 4 minutes. So in the course of that year, they went out on 130,910 falls. Falls made up roughly 1 of of every 5 9/11 calls that they received. And they're saying not only is this overwhelming our abilities to respond to emergencies, responding to falls, this isn't something that's static. We're seeing these numbers increase by 10,000 a year statewide. So this is not an issue that's going down. This is an issue that's going up. And the wording that they're using is that it's increasing at an accelerated pace. And for them, it's increasing at an alarming pace. The other thing that they reported, published in the study, is that according to the CDC, Wisconsin actually has the highest death rate for falls among older adults in the US. So we have a lot of room, a lot of opportunity for improvement to address slip and fall related injuries, not just in our workplaces, but really across the board, in our residences, in public spaces. If you have buildings that are accessible to the public, particularly our seniors, this is something that's front and center. And when you look at these types of numbers, highest death rate for falls among older adults, really it smacks of, why would you want to retire here? It's such a high death rate for our seniors here. So there's a number of organizations aware of these statistics and working very, very actively to try to make Wisconsin a safer place. In addition to the emergency management services here in the state of Wisconsin, which are very specific to what the challenges that we experience here, the Bureau of Labor Statistics tracks incidents that occur in US workplaces. This is nationwide. So in 2022, the last year that we have data, there were 5,486 fatalities in US workplaces. Number one cause of fatalities in the US in workplaces is motor vehicle accidents. And that's been the case for a very long time. Number two, slips and falls. So this has been a huge loss source for companies for quite a while. And when you look at the fatalities associated with slip, trips, and falls, in the US, we had 865 people that did not go home at the end of the day due to a slip, trip, or fall. And basically, these types of incidents continue to be a huge area in which companies are trying to get their arms around control measures to prevent these incidents from happening. Most of the fatalities associated with what's going on nationwide are not same level falls. They're falls from elevation, from falls from as low as starting at 1 feet. And I'm going to review some of those statistics. In the state of Wisconsin in 2022, there were 125 fatalities in Wisconsin workplaces. This number is too high. Of the 125, 17 were due to slip, trips, and falls. We have opportunities for improvement here in Wisconsin. If we're looking at costs nationwide, I have this slide up because this is workers' compensation. This is human toll. This is trying to put a dollar amount to human toll and what this costs people. Unfortunately, insurance costs really don't capture the full scope of human suffering associated with slip, trips, and falls, because insurance only covers part of what it costs the individual. But what we know is that slip, trips, and falls, they're very, very expensive claims. So when you look at the red, that's indemnity. That's what it costs in lost work time. And it's an average of $23,000. Medical costs, probably because maybe surgical interventions, the necessity for physical therapy are quite high. So in terms of workers' compensation costs, slip, trips, and falls are number 3 in terms of expense. But what I can tell you is that it's very difficult in a slip, trip, and fall incident to make the person whole. So if there's a partial disability that the person has to live with for the rest of their life, there's no putting a price tag on that. So insurance companies will tell you, if you look at that $51,000 a year or $50,000 per claim, multiply that by 3 or 4 to get a better estimate of what it's actually costing the individual. But if you talk to somebody who's been involved in a fall incident, it's hard to put a dollar amount on what it's costing them. But here's what's going on in the state of Wisconsin. So those numbers are nationwide. Here's what's going on here. Again, this is only for lost time claims. So this number is much higher because this doesn't take into account the claims involved with medical, where it was medical only, there was no lost work time. But Wisconsin employers paid out nearly $19 million in indemnity-related claims because of 1,871 lost work time claims associated with slips, trips, and falls. And again, if you take that 19 million and multiply it by 3 or 4, you're actually getting a better idea of what it's actually costing Wisconsin employers. Now, I want to spend some time talking about this with you because if you need to make the case that any efforts that you invest in addressing slip, trips, and falls are going to be, it's going to be time well spent, resources well spent, because these are expensive injuries. They come with a high physical toll and human cost, and they're the predominant loss source going on for companies. Now, don't be fooled into thinking that a fall from elevation has to occur at a particularly high elevation for there to be a lot of physical damage. That is simply not the case. The Center for Construction Research and Training looked very carefully at when there were fatalities, what height were people falling? And they looked at that data, and really 1 out of 5 were from heights under 10 feet. So you don't have to fall that far for it to be a fatality, meaning just being 1 to 5 feet off the ground can result in fatality. So climbing up on that chair is not as innocuous as you would think. So that's what's going on in terms of what it's costing us in the human toll. Well, how do we address this? So the Occupational Safety and Health Administration, general industry, has published, of course, standards in which employers are expected to maintain safe walking working services. And these regulations can be found in 1910, 21 to 1930. And these standards provide mandates in which employers must address general requirements, which I'll talk a little bit about, but there's very specific requirements for ladders, stairways, dock boards, working off scaffolding, different fall protection scenarios and what type of fall protection schemes are required. And then, of course, anybody who is operating with a fall from elevation exposure needs to have very specific training. OSHA has recognized that falls from elevation are so problematic that there is a national emphasis program specifically targeting these types of falls. We have way too many people still dying when falling from elevations. So there is a national emphasis program such that when OSHA comes out to do inspections, they will roll in and look at different types of fall from elevation exposures. Now, evaluating this has never been easier with the onset of Google Earth. So prior to me going out to a company from a consultant perspective, I will do a Google Earth shot of the roof of that company. And I'll see, do they have skylights on the roof? Do they have security cameras mounted in the corner of the roof? Where does the roof hatch pop out? Is it right on the edge? Is there no guard railing around the parapet? The parapet's very short. It doesn't serve as fall protection. So there's a lot of technology now that can be used to look at what types of fall hazards exist on rooftops where, this technology didn't exist in the past. Now, I will say that I don't believe that and this is just my opinion, but the standards governing maintaining working surfaces, I don't feel they go far enough in light of how many injuries and the human toll that we're seeing in workplaces. So what I've done here is plucked out some of the most commonly cited general requirements for working surfaces out of 1910. So these are the standards that OSHA will turn to when they find that the employer is not meeting their obligation to maintain safe working surfaces. Very common, all places of employment passageways need to be maintained in a clean, orderly, and sanitary condition. They have to be maintained free of hazards, such as sharp or protruding objects, loose boards, spills, snow and ice. So, for us here in Wisconsin, that's particularly challenging. We have to ensure that we're doing self-inspections regularly and as often as necessary. And again, in the months of November through April, that means we're walking around and doing self-inspections quite regularly because we have a lot of challenges with maintaining safe working surfaces. And then we need to ensure that we're addressing these hazards in a timely fashion. So we identify an issue, and then we need to make sure that we quickly address it to ensure that somebody following right after them doesn't have the same issue and sustain an injury. Now, many times when I'm going out and working with different companies, and I've worked in the public sector as well, with different municipalities and school districts, so many of their efforts are really focused on really low-level controls in terms of looking at, trying to get people to change their footwear and trying to train them on how to walk. And those have their place. But I'm an engineer. So where I like to start is there any way that we can engineer this out? And thankfully, we have a number of ways where, when I started out in describing slips and the loss of traction, there are a number of ways that we can measure this as engineers and scientists and come up with an objective number that tells you this is going to be a problem. Now, this is a common area of debate in my household because my husband is an architect. And so he designs and oversees the construction of schools and businesses. And, what's really slick, particularly hot in construction and architectural design is polished concrete. It's really hot. This really clean design that you see in this middle picture, that's polished concrete. And then, of course, marble is on your left-hand side and granite, really hot. These are really, from an architectural standpoint, they're sleek. From a safety and health standpoint, they're a nightmare. So we can measure the coefficient of friction of these different surfaces marble, terrazzo, granite, porcelain stone, polished concrete. They're really a nightmare from a slips and falls control standpoint. The architects say, well, just throw a mat on it. Well, that creates its own problem. But the fact of the matter is, when you're looking at replacing a floor, or if you're looking at a floor where it's a skating rink, we can look at and measure how problematic is that floor. And so there are standards, American Society of Testing Materials, ASTM, and the American National Standards Institute, ANSI, both have these different pieces of equipment. One on the top is a pendulum, which kind of mimics the action of the human foot coming into contact with the floor. And then the lower is what's called the Bach 3000. It's real space age type stuff. But we can get objective measures of this, and we have criteria. The ASTM standard, anything with a measure of 36 or above is considered low slip potential. If it's below 25, we have a very high slip potential. For ANSI, we've got measures as well, where and recommendations. So tile manufacturers will publish coefficient of frictions on their tile, on their product, so you know out of the gate how slippery that surface is going to be. Now, controlling snow, ice, and water accumulation, particularly in the state of Wisconsin, really becomes a challenge starting in the months of November and going through until April. And sometimes that can go as far as into May. So the accumulation of, if you have areas in your parking lots, on your sidewalks that were not addressed during the summer months, and now you have ice accumulation, you have water accumulation in those areas. Those are areas that are going to require you to bird dog them very closely, but not just exterior exposures. We have interior ones as well, of course, you know, in our maintenance shops where we have grease and oil that can accumulate on our floors, in our kitchens where you can have a greasy floor buildup, particularly if you're operating deep fryers. So in terms of looking at controlling slips and falls, I say this from an engineering perspective, is do you even have the right flooring for that area? So, you know, areas where you have high traffic, where there's water accumulation, like in kitchens or in bathrooms or in lobby areas, are you fighting an uphill battle from the get-go because you do not have the right flooring? And ripping out flooring is not an inexpensive proposition. But again, when we look at these costs, you can make the sale that it makes sense, particularly if you have a history of slips and falls. Now, we'd rather you not wait until you have a number of individuals out on lost work time cases. We know this already to be the case. You don't need to figure it out for yourself. We've got a well-established history of it. So starting out looking at the floor itself, but going even one step further, how are you cleaning that floor? Because your floor cleaning protocols actually can be contributing to the problem. So if your cleaning chemicals aren't being used correctly for the type of floor, you're not using them per manufacturer's specs, you're not looking at it, you're not matching your protocol with the contaminants that you could have on the floor or have any kind of floor cleaning procedures, what you could be doing might not be improving the situation, but making it worse. On top of that, you could be using aerosol products like furniture and polish or glass cleaners that once they settle onto the ground actually make the floor more slippery. So again, this involves like stepping back and looking more specifically at engineering out some of the traction issues that we're seeing. Now, not only do we see loss of traction in lobby areas, in bathrooms, in kitchen areas, parking lots, sidewalks, we also will see issues with really slick exposures with equipment leaks. And when I walk around a manufacturing facility or a maintenance shop, and there's a piece of equipment and there's oil, it's really slick in and around the equipment. And they'll throw down absorbent or they'll throw down a boom, but they don't address the root cause of the leak, which requires more homework. It requires more elbow grease. But essentially, throwing down the booms is a Band-Aid. So really, sitting down with maintenance and figuring out how is this equipment being maintained? Is the equipment being operated with its intended design? Is the equipment being overloaded? And then is there contamination, high temp, or abnormal vibration issues going on that may explain why that equipment is continuing to leak grease or oils onto the floor? Now, bathrooms, again, are this is something that has been studied exhaustively in the retail sector because of the amount of slips and falls and the traffic they have people going in. Now, I encourage you I took this picture at the Harley Davidson restaurant bathroom, because I'm very geeky about these things. But you see here how they have the faucet and then they have the tan towels and the garbage all right next to each other. They still have cracking on the flooring below because people keep dripping their hands as they're reaching over. So that's a set source of constant. It's a wet spot. You'll see, I think it's a Marcus Corporation, has now included the towels that you pull off to dry your hands and the garbage all within the same countertop. So people are not walking with wet dripping hands all the way over to the dryer. So there's things that can be done in terms of layout of the bathroom that don't require you to practically be in the bathroom 24/7 to keep the floors dry. The other thing, of course, is maintaining a bird's eye of, are the sink and plumbing leaking onto the floor? And do you have good lighting in the bathroom? Weather-related controls, again, here in the state of Wisconsin, if your parking lots and sidewalks are not in good condition, and those were not addressed during the summer months, when you can, spread asphalt or pour concrete, these are going to be particularly problematic during the winter months. So companies that are very aggressive about maintaining their parking lots and sidewalks in good condition, they're hiring contractors well before the season starts to remove snow and ice prior to anyone showing up. They're purchasing all the equipment they need pre-season. The position of matting both outside and within the facility, it's a little bit of a science. It's how you get ice and snow off people's shoes and how long of a runway you need to get that snow and ice. So off the shoes, off their footwear. So many times the mats are too short. There's not enough walk off. And they become saturated very quickly and they're not replaced quickly enough. But also, this is the opportunity to have plans in play for floor dryers, wet dry vacs, even setting up benches so people can take off their boots, put them in a bag and not track snow and ice through the whole facility. And again, this is really popular. These walk like a penguin, because penguins have really their center of gravity is very, very low. And so these walk like a penguin efforts are very, very popular. But if you're relying on this as the one way you're going to break into controlling your slips and falls, you've got a lot of room for growth. Encouraging people, of course, to wear appropriate footwear, but ultimately they're going to show up in footwear that they think makes sense. This is a low-level control. One of the other things, of course, to consider is how your gutters are draining water onto sidewalks or parking lot, heavy areas of traffic. If those things can be relocated, you might move an ice rink from a place that people are commonly walking. So trip hazards, really, we're seeing more associated with poor housekeeping, loose flooring, carpeting, or matting, extension cords, pneumatic hoses, objects that are projecting into aisleways. When we look at sideway heave here in the state of Wisconsin, it doesn't take much for it to be a trip hazard. It can be as low as 55 millimeters, and that's going to be something that you're going to see a trip hazard associated with. So opportunities for trip hazards, most of the time I see extension cords running across floors, pneumatic hoses running across floors. And this is really where self-inspections are absolutely key. So walking around, if you have a safety committee, instead of doing wall-to-wall inspections, particularly now in the state of Wisconsin, focus on slip, trip, and fall hazards, where that's all you're looking for. And man, can you make a lot of progress when you really hone in on this law source. And really working well with facilities to make sure that these walking areas are being maintained safely and that areas and lighting are well lit. So it's not shadowy and people have a clear view of their pathway. Let's talk now about fall hazards. Now, in general industry, the criteria for where OSHA expects some sort of fall protection system to be in place is 4 feet. In construction, it's 6. Now, I find this because I've worked in construction for many years. Construction workers are not built any differently, and they're not subject to different laws of gravity than anyone else. But that is what the standard requires. 1926 CFR is what governs contractors. 1910 is general industry. What are we looking at in terms of elevated surfaces? Elevated work platforms, runways, stairways. Those are above grade, but what about open pits, tanks, vats, or anything that's below grade? On top of that, when there are mezzanines or areas where people choose to start storing items above an office area, so they're getting up on top of a space that was not designed for that, can they fall right through it? So we're looking at all of these different potential exposures when we're walking around doing our self-inspections. Okay, so this is a little bit hard to see, but this is an example of a work platform at a piece of equipment where it's 48 inches and there's no guard railing on either side. There's nothing really preventing an individual from walking off this work platform. 4 feet becomes an exception when, if you can see on the right-hand side, there's an expectation of some form of fall protection if what you're falling into is a dangerous piece of equipment. So while this is less than 4 feet, there's still an expectation of some form of fall protection. Now, many times what companies are turning to for fall protection are guardrail systems. And guardrail systems have quite an extensive list of criteria that you need to be aware of. So a standard guard railing, as pictured here, has a top rail that's 42 inches plus or minus 3 inches with a mid rail. If you can kick a tool or item or product that you're storing on the elevated platform off the platform, you need to have a standard toe board. And that guardrail can't be rickety. It's got to be able to sustain a force of 200 pounds exerted on any direction on the top rail. We also look for stairways that can pose a slip, trip, and fall hazard. This one is particularly, this stair has a lot of problems associated with it. It does not have proper guard railing on either side, so somebody could grab a hold of it should they start to fall. It doesn't have slip-resistant treads. The treads do not have a uniform rise and run. And there's items, as you can see, hammers and tools left on a stair that people can trip and fall over. And the lighting in the area is poor on top of it, so people can't see that they're about to trip over a tool. Now, OSHA has very particular criteria about when you have to have handrails or guardrails, and it's based on the width of the stair. And I have that criteria listed here. One of the things, again, that's big subject of debate in my house is OSHA's standards for stairwells are different than the International Building Code. So again, my architect husband is building new construction. Wisconsin has adopted 2015 International Building Code. International Building Code is what's indicated on the right-hand side. OSHA standards is what's on the left-hand side, which is why you might see a brand new building that's got different criteria. Now, again, International Building Code typically will be more restrictive, but that's why you might see different systems out there and why. Wall openings and floor holes, again, present a significant exposure in terms of fall from elevation. Wall openings are defined, and typically we'll see these types of hazards associated with when a window maybe is being replaced, so windows removed, or sometimes in academics, it was back when like a wall unit was removed and there was then an opening. It's at least 30 inches high and at least 18 inches wide, where, again, like elevator shafts are a good example of this, where we'll see fatalities of people falling through these openings. Floor holes are defined as anything that's 2 inches in its least dimension. And I get a lot of pushback from this, particularly when I was in the construction industry. It's like, 2 holes, come on, Julie, give me a break. What's the big deal? Well, here's the big deal. This is a contractor that I was working with on a job. This was in a boys' bathroom, and they were installing construction. They were pulling wire overhead and installing conduit. If you can see on the bottom, there's a plywood wood cover there. But unfortunately, there were holes in the floor that were kind of cut in the shape of a clover leaf, and that board didn't completely cover them. So the ladder walked just a little bit, and I had a 23-year-old electrician working with his arms in the air, and that leg went into that hole and threw him off the ladder. And what happened is he shattered all of the bones in his upper arm on his right arm. And for an electrician, not to be able to lift your arms above your heart level really puts you out of the game for quite a while. So he's now got 14 pins in his arm, and he's only 23 years old. He was gone for quite a bit of time. So when people say, what's the big deal with a 2-inch floor opening, this is the big deal. Now, there's all kinds of, the internet is rife with examples of people misusing ladders, using the wrong ladder for the job, standing on the top step of a ladder, ladders that are not properly maintained. This photo on the right-hand side, actually, I went out to a company, and this is what maintenance was doing. They had this wooden ladder here. They got up on the top step, and they had balanced a pallet on process piping. So they took a step off this top ladder and then stepped on this pallet, and they were working off the pallet. So there's examples abound of improper ladder use. What I'd like to point you towards is, I'm not going to go slide by slide, but NIOSH has an absolutely outstanding free app for you to use to walk around and not only do training on ladder safety, but also do ladder inspections. And there's a really slick angle measuring tool that you can use for extension ladders to measure, do they have the pitch of that ladder set up safely? So I'd strongly recommend that. Now, ladders and falls off ladders are such a huge problem that the American Ladder Institute has earmarked the entire month of March as a National Ladder Safety Month. And their goal is to reduce ladder-related injuries by 500,000 every year. It's very ambitious. They have a ton of ladder safety training resources. And I strongly encourage you, at the beginning of the year, 2025, maybe make a decision to be a part of this Ladder Safety Month in March. Now, scaffolds present another issue in terms of another exposure for falls. Again, the expectation is that you don't need fall protection if you're working at 10 feet. That 10 feet is where the expectation of guardrailing kicks in. But so often when looking at scaffolding setups, we have individuals working at 10 feet or greater without guard railing. They're overloading the scaffolding. The scaffolding is in poor condition. It's not set up properly. And in the state of Wisconsin, again, when you set it up, you don't put mud sills on the bottom because it was dry when you set it up. Well, now it's raining and now the whole thing's sinking. So generally, we see issues with scaffolding associated with poor assembly, poor access, and untrained individuals setting up the scaffolding and untrained individuals working on the scaffolding. These are the most commonly found issues when we're walking around looking at scaffolding setups. Again, that requirement at 10 feet, ensuring that the guardrails are on all open sides, and that there's a competent person who's inspecting the scaffolding for visible defects at every work shift. And again, generally when I find poor scaffolding setups, I'm immediately asking, who's the competent person that's inspecting this? And that's where everything really starts falling apart. Again, a completely free resource here is available through Safety Culture. Safety Culture offers a free app, and they have a free scaffolding inspection app that can be used to document scaffolding inspections. It's kind of a slick tool. And again, if you have a limited budget, it's very attractive. This is basically off the OSHA website in terms of expectations for safe scaffolding setup. And again, the link is below. OSHA has a lot of resources in terms of scaffolding inspections and scaffolding training. Scissors lifts. Another area in which we can see pretty catastrophic falls from elevation exposures. In turning to the manufacturers of scissors lifts, this is what they'll tell you is the top reasons why they'll see tip overs or falls from scissors lifts. One of the top, they're moving the lift while it's in elevated position, and that high in the air, you cannot see the conditions on the ground. They come into contact, a forklift plows into the scissors lift or a truck or another motorized vehicle and takes the lift out, and that operator is going down. Overhead crane, a contractor comes in, they're working in an area, poor communication, overhead crane takes it out. Or they make contact with process piping. Now whatever's in that piping is engulfing the person that's in the scissors lift, and the first thing they want to do is jump out of it. Surface conditions are unstable, which takes the lift over. Poor weather conditions, particularly windy conditions, take it over, or the operator does not position the scissors lift safely. There's no PM on it. And the operator has the wrong scissors lift for the job and they start climbing those rails. Or they put a 5-gallon bucket on the bottom of the lift and they climb up on top of it. Another issue, of course, if they're doing these things is that they really haven't been properly trained. So really, when I'm looking at scissors lift, I'm looking at the fault protection systems. I'm looking at how they're using it. And I'm talking to the operators to make sure that those feet are never coming off that work platform. And I'm looking at traffic control and seeing, are they positioned at a blind corner where a forklift can come around the corner and just plow into them and take the whole business over. So positioning and training for anyone using these lifts is absolutely critical, in addition to how the lift is being maintained. There's a really slick tool for proper use of aerial lifts that's available. NIOSH has an aerial lift hazard recognition simulator that's kind of slick that I wanted to make you aware of. And I'd like to end my presentation today talking about a fatality that has stuck with me my whole career. I was the Environmental Health and Safety Director at the Milwaukee School of Engineering. This is the campus center building at 1025 North Broadway at Milwaukee School of Engineering. Before I worked at MSOE, which was in 2010, in 2001, the roof of this building was being replaced by a roofing contractor hired by MSOE. This is a ballast roof. So they were ripping off this roof in July of 2001. And on Thursday, July 26th, 23-year-old Matthew Schrampka was just doing this job as a summer job, was not an experienced roofer. He was working on this roof with this roofing contractor. And at around 11:30 in the morning, he struck his hand with a hammer. Matthew was not an experienced contractor. So what happened was I located the water cooler right on the edge. So no one working on the roof, they had a safety monitor on the roof at the time Matthew was there. Now the safety monitor, the role of the safety monitor is essentially to yell at people who are getting too close to the edge. The safety monitor and the other people on the crew never saw Matthew come off the roof. The first inkling they had that anyone had fallen off the roof was the ambulances screaming up Broadway. This is where Matthew fell off the roof. This parapet height is 9 inches high. So best guess, Matthew went to get water for his hand and fell off the roof and fell 50 feet onto the sidewalk on Broadway. Now, 2 individuals did see Matthew fall from the building, and I find these 2 individuals to be quite extraordinary. 2 bystanders rushed to Matthew, who was laying on the sidewalk. One was a businesswoman who was downtown for a business meeting, and the second was a retired teacher. They were both parking their vehicles and saw Matthew fall to the sidewalk. And the retired teacher, I find it extraordinary that these people ran over to be with Matthew to try to help him. The retired teacher felt for Matthew's pulse, and he said, as the fire engines and ambulances approached, he felt Matthew's pulse getting weaker and his respiration becoming shallower. He knew that he was holding the hand of a man who was dying. So the parents of Matthew have actually taken great comfort that he was not alone when he died. But when I came to campus, that exposure still existed. And what I found was that there were a lot of other groups accessing that roof, and there was still no guard railing on it. So all these groups were going up on the roof. The roof still did not have adequate fall protection, which was a huge concern to me, that 10 years after Matthew's fall and death from that building, that there was still no guard railing on it. So I approached the CFO at MSOE, and we both agreed no one was ever going to come off that roof ever again. And we went through a hierarchy of controls looking at hazard elimination, the erection of guard railing, fall restraint, fall rest, or administrative systems. And what we decided is this needed to be guardrailed. So this is the area where Matthew fell off the building. That building now has guard railing. So unless somebody climbs over the guard railing, nobody else is coming off that building. Of course, guard railing is not the only option when you're looking at fall protection options. Personal fall arrest systems are another option. These are systems that require training. They require understanding. I see a lot of individuals tying off to anchorage points that aren't rated for them. They are using harnesses that are not correctly worn. They don't understand how to inspect the snap hooks. We've got a lot of room for growth when we're looking at the installation of personal fall arrest systems. You know, one of the predominant concerns is when someone is wearing a harness and tied off to an anchorage point and think they're not going to hit the ground. And it turns out they significantly underestimate the amount of distance they need to stop. So, for example, if they were on, if this was 13 feet in the air, the anchorage point here, and you thought that, well, this'll stop me in 12 feet, you'd be wrong. And you'd be operating with the misconception that you're protected when you're not. You're gonna hit the ground. So it's very important that individuals working at elevations receive proper training on how to tie off, what the nature of the fall hazards they're exposed to, how to correctly wear this equipment, how to properly inspect it. At Milwaukee School of Engineering, we adopted a written fall protection program. This was a tribute to not only Matthew, but any roofer employee that's fallen and become significantly injured at work. At MSOE now, there's a pre-planning program for new construction, a number of fall protection systems on all of their rooftops, a very strict fall protection requirement at 4 feet. And on top of that, while it's not required by law, because of the fatality that occurred at the campus center, no roofers are allowed to use safety monitoring systems on MSOE roofs. Is it still legally, technically permissible? It is, but not at MSOE. With that, I hope I've given you a sense of how devastating slip, trips, and falls injuries are, how much they cost, not only workers, but the people of Wisconsin, how important it is to identify slip, trip, and fall hazards in your workplace to mitigate those risks, and the need to really dig in when looking at controls to prevent slips, falls, and trips in your workplaces. I realize that I brought us right up to noon. So if anyone wants to stay on the call, because you have questions, I love fielding questions. If not, thank you for being a part of our webinar and taking the time to learn more about this issue. And I hope we've created new advocates who can go out and really make a difference in your workplaces to prevent that next injury from happening.
All right. Thank you, Julie. As we mentioned, we still have a few more minutes if people want to ask questions. Also, the recording will be available on WisCon's webpage sometime, probably late January.
So giving people the opportunity to kind of absorb what's a lot of information. I could talk about slip, trips, and falls for days, actually. I tried to distill this down into some really practical need to know info that I have seen more often than not to try to help. But if you can think of questions or need technical resources in this area, we jump at the chance to help. So please give us a call if you're struggling or you need to make a pitch as to why changes need to be made, or if you need help with training, or you need to identify, maybe a vendor to come and take some measures of coefficient friction of floors because you're thinking, man, this is just a skating rink in here and we really need to look at replacing these floors. We're there to help technically support you to get you to a better place.
All right. We're not seeing any questions, so we want to thank everybody and wish you a safe and happy holidays.